So actually for the table we show here, besides reading the table in the rows, we can also read the table in the columns. Let's assume if we read the table in the column, this column, in other words, by this column we can find the data records which has this G value, this attribute with value FOO, right? By retrieving this column, we can find a vector of bits 100, 100. In other words, from this column we find that the first record and the fourth record, they will have a G value to be FOO. It will be similar if we retrieve this column instead. We can find the records with G value equals to bar, right? BAR, which will be the second column as well as the fifth column, right? They both have G value to be bar. It will be similar for the last column. It will correspond to the third as well as the sixth instance, right? They both have G value to be equals to BAZ. This is another way for reading the columns. We'll show that later. This will enable us to do query in a very fast way because we can retrieve directly according to the bits to know which records has a value equals to what value, right? So this kind of bitmap enables us to store the data in a much small space. Also, this kind of bitmap enables us to do query in a much faster manner, especially for the range queries. Here we show another example. Let's assume we have a custom for jewelry store. For the customs, we have a table for storing their information. And we have two attributes for the custom. The first one is age, and the second one is salary. We store all the custom age as well as salary information into the table. And then we will have some queries for finding some custom inside a range of age as well as in a range of salaries. How can I do this in a fast manner? Of course, we can do it according to the conventional index table we showed before, right? Like B+3. Here we decide to construct a bitmap-based index table instead. How can we do this? So formally, we can represent this data into a bitmap. Here we read the data into columns. We showed before with a table like this, right? We can read the table in the columns. Given a value of attributes, we can find the records which has one value which has this FOO for the attributes, right? It will be similar here. Given the age attribute, we can construct a bitmap for it. Here, if we read the table into columns, we can get the given one value for the attribute, and we can find the records with this value inside the database systems, right? So, for example, let's assume, so according to the table shown in the previous page, we have 12 records, right? We have 12 records. However, for the age attribute, we have 7 different values: 25, 45, 50, 70, 85, and 30, right? As well as 60. All the remaining, they are the same value, right? In other words, we can construct a column or of bitmaps for the age, and if we read the bitmaps according to the columns, then we can rewrite the column in this way, right? We have 7 different values, and we also have 12 different records, right? Given one value for the age, and we can get its corresponding bitmap, which will be 1000000 1000, right? In other words, these 12 bits correspond to 12 different records, we showed previous page, right? And this one value denotes the first record as well as the ninth custom. They both have the age value to be 25, right? In other words, these ones inside the bits denotes a record with certain value for the attributes. So this is a bitmap for the age attribute. In a similar way, we can also get the bitmaps for the salary attribute of the custom as well. And we have about 10 different values for the salary of the customs. And we also have 12 customs. In other words, for each value of the attribute, we also have bitmaps with 12 different bits. And the one values inside these bitmaps denoting the corresponding customer record, they have the value for the attribute. Now for the 60, we know the first and the second custom, they both have a salary to be 60, right? It will be similar for the remaining entries as shown in this page. So according to these bitmaps for different values of attributes, we can retrieve the bits, the vector of bits, which can indicate the records with certain value for the attributes, right? And based on it, we can further answer some queries. Let's assume we want to find the jewelry buyers or customs with age in the range of about 45 to 55, as well as salary in the range about 100 and 200. How can we find these kinds of customs? So according to the first age, this table, right? For the 45 to 55, we have different values in the range 45 as well as 50, right? We can have two different bits. These two bits, we can retrieve them, right? This will indicate the customs who are in the range about 45 and 55, right? Because we want to find the custom who are in this range. In other words, we can just all of them together. All these two bit vector together, we can find the customs who are in the range either 45 to 55, right? We can find the custom who are in the range from 45 to 55, right? In other words, they are either 50 or 45. We can all them together, we can get a vector which will be 0, 1, 1, 1, 1, right? And 0, 0, 0, 0, 1, 1, 0. In other words, the second, third, fourth, and fifth, as well as the 10th, 11th, this custom, they both have the age in the range from 45 to 55, right? And besides this, we can further find the scenery, the bitmaps, or the bit vectors. So for the scenery in the range from 100 to 200, according to the previous page, we show that for the scenery in the range from 100 to 200, it will be 100, 110, 120, and 140, right? These four are different bit vectors. We can retrieve them together, right? And we can retrieve them, and we also can all of them together, right? And it will result in a vector about 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 0, right? In other words, the 4th, 5th, 6th, and 7th, these customs, they will have the scenery in the range from 100 to 200, right? So this is the vector for the scenery, and this is the vector for the age. Because according to the query question, we want to find the customer who are in the range of this age and the scenery in this range, right? In other words, we can add this vector together with the vector together, right? It will result in a bit vector. It will be 0, 0, 0, 1, 1, and all 0 for the remaining ones, right? In other words, it indicates the 4th and the 5th, these customs, they will have the age in this range 45 to 55, as well as scenery in the range from 100 to 200, right? And it enables us to do a query in a much faster way compared with conventional query processing methods. So you can also compare this result versus the true table we showed before, right? The 4th and as well as the 5th, they will have the age in the range from 45 to 55, or the scenery in the range from 100 to 200, right? These are the true results we should return. Okay, so this is the way we can do the query based on bitmaps. It will be very efficient and also effective for many of the database systems. Okay, so this is about indexing we want to cover for this section, and thanks so much for your attention. And we will move to the new section for the query processing.